So the other two positions of this spool are much easier to visualize when we get to part 2 of this tutorial, when we bring the animated circuits into it. But for now, what you would have to envision is if this spool shifts to the left here, what would happen is this pressure coming in at the P port here would actually be exposed to the A port. If you can envision this spool shifting over, that correlates with this position right here with P going to A. And at the same time, B is already exposed to T in the center position, but it would be probably even have a little bit less of a pressure drop because this spool would shift over more and make the passage from B to T that much less restrictive. So that's what's going on when the spool would shift left. And when that happens and we put pressure and flow into port A, we know that our cylinder is going to extend. If it goes the other way and it shifts to the right, same thing. You've got to envision this P pressure here. Once this spool comes off its land, it's going to open up a flow path to B, and that'll end up at port 2 of our counterbalance valve. So this spool shifting to the right would be equivalent to this spool position coming over here in our schematic, P to B, A to T. And when pressure goes into this B port, it goes into port 2 of the counterbalance valve. Well, what is the counterbalance valve? Counterbalance valves' jobs are to manage pressures and flows coming from overrunning loads. So what you have to envision, and it's not depicted here, is something trying to pull this cylinder out, make it extend, some kind of a load on the rod. Maybe if it was mounted a certain way, it could be a gravitational type load depending on how it's oriented. But we don't want this cylinder to run away from us when we're extending it, okay? Because that could make the pump cavitate, that could make us get air in the system, and more importantly, we want to have precise control of the load. We want to be able to modulate it properly and safely. So that's what the counterbalance valve does. So the counterbalance valve is a 3-port device. It has ports 1, 2, and 3, just like here in this depiction of the cross section. Port 1, 2, and 3. And what happens is when a counterbalance valve usually has a free flow check valve on this side to allow flow to go in the side of the actuator where you're not trying to modulate flow. So right here you've got a free flow check valve, so flow can go from 2 to 1 relatively easily. It's just got to overcome the cracking pressure of that check valve. So likewise here, 2 to 1 would be over this. This is the poppet type check valve here. Once the pressure reaches the cracking pressure of this small check valve, then you're going to get flow from 2 to 1. Okay, 2 to 1, and that will make the cylinder retract, obviously. 2 to 1 will make the cylinder retract. Going the other way, it's a little more complicated. If this cylinder is trying to extend and flow is coming out of the rod end, what happens? Well, if it comes into port 1, it can't go around that same check valve to port 2 because it's blocked. It'll seat that check right there. So it has to work over this counterbalance valve. And for that to happen, it needs to have a pilot signal at port 3. Okay? So if we are to extend this cylinder at all, we need to have a pilot signal from port A here into port 3 of our counterbalance valve, moving the counterbalance valve piston off of its land to allow flow from 1 to 2. Again, this will be something that's much easier to visualize once we get to the animation. But for now, that's how a counterbalance valve works. Here's a schematic. Here's a cross-sectional view of one. Spring adjustment here. Spring here. Check valve right here. Check valve here. The cylinder is the easiest component to draw a correlation between from the schematic to the real world symbol. Here's our schematic symbol. Here's the real world symbol. They're both double acting, meaning they go in both directions. It's not a single acting cylinder. If you want to extend it, you've got to put flow on the piston end here. If you want to retract it, you've got to put flow on the rod end here. Same thing with the schematic symbol.